Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very exponential complex equation. We have I to the power z equals zi, and we're going to try to solve for z. I'm also going to show you a result from alpha if I did not forget to include it in this PDF. Anyways, we have this equation I to the z equals zi. Recently we've done a similar problem which was titled an exponent that doubles, because it was I to the z equals 2i. Now we have an exponent that multiplies by z, okay, the I by z. So in general, obviously, when you raise I to any complex power, it's not equivalent to multiplying the I by the same complex number, right? This is a specific situation where we're looking for z. Z is the unknown, it's the variable, and I is a constant. In case you didn't know, I is one of the square roots of -1, or you can define it as I squared equals -1. All right, and a complex number is a plus bi, where a and b are real numbers. If you are new to complex numbers, go ahead and check out my lecture videos. I made a playlist where I go over the basics of complex numbers. So let's go ahead and take a look. We could probably talk about a couple different solution methods here. Just talk about some of them. For example, I can just try to write I to the z using the exponential, right? How can I write I to the z? There is a general formula for complex exponentiation. W to the power z can be written as e to the power z ln w. In this case, w happens to be I, which is also a complex number, but at the same time, it's an imaginary number. I for imaginary, okay? So, what about the right-hand side? I have a zi. Can I write it as e to the power ln zi? Because think about it, x is e to the power ln x. That's true for real numbers. What about complex numbers? That should also be an identity, right? I think so. So now we can go ahead and set these equal to each other. Let's do it. E to the power z ln w equals e to the power ln zi. And then we can go ahead and write this as z ln w. By the way, what I mean by w is I, so let me go ahead and back up a little bit. This is going to be an I, and this is also going to be an I. Cool. So we get z ln I equals e to the power, not e to the power, we already taken care of it, because what we did was natural log both sides, and this gives us ln zi. No, I was right. It was ln because it's e to the ln. Okay, here we go. So now we kind of have like ln's on both sides, and you may be tempted to write it as z equals ln zi over ln I, and then maybe even do this. Can we write this as ln z plus ln I over ln I, and then even separate it into z equals ln z over ln I plus 1. Okay, I'm not exactly sure where this is going to lead. I just tried, but I want to stick to this equation. Now, how do you solve such an equation? I want to be able to use a very special function by Lambert. Are you familiar with that? I think we talked about it very many times. It should be familiar to you now. But in case you're not familiar with that, I want to take something like this as an input, and I want to apply the w function on it so that I can get a t out of that. Make sense? So my goal is to get something in this format, t e to the t, right? How can I get it from here? Well, I kind of have an ln which I can turn into something else. Maybe I should bring the variables together, this one and that one, right? So here's what I'm thinking. Multiply both sides by 1 over z, or z to the power -1. That gives us z to the power -1 multiplied by ln zi equals ln I. ln I, we can take care of that later. Don't worry about it right now. It's just a constant, obviously, just another complex number. And this one here, can we work out something so that this will turn into te to the t? Well, these quantities have to be equal in order for that to happen. They're different. For example, this is a zi, this is a z to the power -1. So one thing I can do is put a minus sign here and put a -1 as a power, right? And then that'll take care of this, but it's going to give us z to the power -1 multiplied by I to the power -1, which is -I. So I still need a -I there. Well, I actually have the negative sign, so all I have to do is multiply both sides by I. Let's multiply both sides by I now, and that should do the trick, right? I think. So now this is what we have. ln zi to the power -1. And by the way, this is zi to the power, this is zi to the power -1, because I to the power -1 is 1 over I, which is -I. Okay? Makes sense? Now, what do I have? I have ln zi to the power -1 multiplied by zi to the power -1. Great. It's pretty close. It's not t to the t, but we can turn it this way. We can kind of write the zi to the power -1 as e to the power ln zi to the power -1, and then that'll do the trick. Now this is going to be my t. Make sense? T e to the t will be satisfied. What about this? And this one we could probably write as follows: ln I times e to the power ln I, and this will be our c, and then t to the t, c to the c. Maybe we can directly set those equal to each other and go from there, right? Cool. Now, if you apply Lambert's W function on both sides, you're going to get something, hopefully, from here. Let me go ahead and try something else, because this doesn't look very good to me, and I wanted to make just an attempt as my first attempt. But now I have a better idea. I to the z equals zi. And by the way, a third method, which I'm probably not going to go into, could be we can divide both sides by I first and write this as I to the power z minus 1, and then that equals z, and then maybe we can multiply both sides by the reciprocal of this, and I put everything on the same side, like z times I to the power 1 minus z, and then from here we can use e to the power ln something, and maybe use Lambert's W again. I don't know if that's going to work, but I just wanted to briefly mention the third method before the second one, because it's more fun, right? Okay, so the second method is going to be as follows. I want to go ahead and replace I with its polar form, which is e to the power I pi over 2. And then, of course, I'm going to raise it to the power z, and that'll equal zi or iz. Now, can we multiply the exponents? That's a really good question. If you have z to the power u to the power w, is it the same as z to the power uw, and under which conditions? Because for complex numbers, we do know that this is not always true, but it's sometimes true. Is it true in this case? I don't know, probably. Anyways, I think it is, because I'll show you at the end. So if you go to multiply everything together, you're going to get the following, and this is equal to iz. Now I want to use Lambert's W function, but let's go ahead and keep the z where it is and bring this over, because exponents are easier to handle. So let's go ahead and bring this over to the right by division, and then bring the I over to the left by 1 over I, which is going to be -I. So we're going to get the following. -I equals z times e to the power -I pi z over 2. Awesome. We got something nice, but we're going to make it nicer, because notice that my t is not formed yet. This is going to be my t, because t e to the t, remember? But I do need to multiply by something. These are constants, so we can easily manipulate that. Let's go ahead and multiply both sides by -I pi, -I times -I pi, and then that'll give us equals -I pi. Oh, by the way, I forgot to divide by 2. -I pi over 2, that's what I should multiply by. Z times e to the power -I pi z over 2. Same thing, right? Now we got our t and e to the t, so this is my t, right? And now if you apply Lambert's W function on the right, you're going to get -I pi z over 2 equals w of I squared, which is -1, and that's going to be -pi over 2. And then, of course, I'm supposed to solve for z. Come on. Let's multiply both sides by I first, because when you multiply by I, this is going to become 1. When you multiply by I, this is just going to be IW something. And from here, we're going to get z if we multiply by 2 and divide by pi. Okay, so z is going to be from here 2I times w of -pi over 2 divided by pi. So what is the w of -pi over 2? That will be a really good question, right? You could try to manipulate it like what is w of negative pi over 2? Maybe write it as w negative 1 times pi over 2, and then replace this with I squared pi over 2, and then you can kind of write this as I times I pi over 2, and you're hopefully going to get your t from here. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.